Human Immunity Presentation Notice by Emil Iliev. Welcome everyone. This is a presentation on human immunity produced and present by Emil Iliev. Human immunity is a complex system of defense mechanism protecting our bodies against various pathogens and diseases. During the presentation, I will be covering the following topics: the first and second line of defense, the third line of defense, self-recognition and tolerance, specific immune system disorders, the categories of acquired immunities, the immune response to vaccination, the concept of herd immunity, vaccination programs and factors affecting vaccine uptake, the benefits of vaccination. The human body has three lines of defense. The first and second lines of defense are non-specific, responding to all pathogens and in the same way. These defense are known as innate immunity. The first line of defense comprises of physical and chemical barriers. The largest, most vital, non-specific defense of the body is the skin. The skin comprises of three layers. The first layer is the epidermis. The skin comprises of three layers. The first layer is epidermis. The second thicker layer is the dermis, which contains blood vessels, nerves, sweat glands, and hair follicles. Deepest layer is the substances layer, offering shock absorption and composite of nerves, blood vessels, collagen, and fat cells. Mucous membranes. Further to specific protection is provided by mucous membranes lining the surface of the eye, nose, mouth, urinary and digestive tract, and the lungs. Macros helps safeguard the more delicate cells. The nose and throat also contain hair-like protections known as cilia. The digestive tract provides further protection against harmful microorganisms. The stomach produces hydrochloric acid, which has a pH level too low for most bacteria to survive. Pancreatic enzymes, bile, and intestinal secretion all act as chemical barriers against infection. Second line of defense, inflammatory response. Damage to the skin or infection can result in pathogen occasionally making past the physical barriers in the first line of defense, the infected area will become swollen, red, inflamed, and painful due to the series of non-specific biological inflammatory responses referred to as the second line of defense. Pathogens and debris that have entered the body are targeted and qualified, broken down, and destroyed by macrophages and neutrophils found with tissues and blood, a process known as phagocytosis. Once identified, phagocytosis use their cell membrane to enclose and consume the pathogen, create a phagosome. Acquired or adaptive immunity isn't present at birth and is developed over a lifetime. It can be acquired actively or passively via infection or disease by exposure to another person's antibodies or through a vaccine. Non-self antigen are present within each pathogen, and when the immune system entirely encounters them, the body generates the production of new antibodies, resulting in immunologic memory from the exposure. White blood cells. The immune system line of defense against infection and are white blood cells, also known as leukocytes. Numerous variants exist, each serving a specific purpose. White blood cells account for 1% on the blood in a body and are produced with home marrow. Some are present from birth, while others are part of our learned immune system. Mycocytosis can different into debris cells or macrophages are required. They cannot. They account for around 5-12% of all white blood cells, and their primary function is to clean up damaged cells. Basophils release histamine to trigger a non-specific immune response, which can cause inflammation and constriction of the airways. Neutrophils are granulocytes and are the first cells to respond to infection or injury. They account for around 50% of white blood cells population and signal the response of other cells to help fight pathogens. Eosinophils are in high concentration in the digestive tract and are vital in fighting parasitic infections. Lymphocytes are in the lymphatic tissues of the body and comprise of B and T cells and natural killer cells. They provide specific immunity and each have distinct roles. Maturation of B cells happens in bone marrow, where they can become plasma or memory cells. They are responsible for immunological memory and helping alert T cells. Plasma cells secrete antibodies into the in the circulatory system to combat the pathogen when exposed to an antigen. T cells originate in home marrow but mature in the tumors and migrate to the lymph tissues and bloodstream once full mature. Perform in produced by cytosis T cells, which also secretes enzymes that kill infection and destroy cancer cells. Immunoglobulins have two main functions. First, as cell surface antigen receptors that allow for cell signaling and activation. Second, as soluble effector molecules that can attach and destroy antigen remotely. They comprise of 4 chain. IgG accounts for 70-75% of human antibodies. It is passed from mother to unborn child via the placenta, providing protection until the infant's immune system in full develop. IgM are created by B cells and are first to respond to antigens and are specifically harmful to bacteria. AGA is prevalent in bodily secretion and is vital in defending entrance ways into the body. IgE plays a critical role defense against allergies and parasitic infections. The exact function of the IgD is unclear, but is thought to be involved in deciding whether antigens activate B cells. One of the most imperative function of the adaptive immune system is able to distinguish between a foreign antigen and a no antigen to the host. MH1 and MH2 are alike and serve similar function. However, there are some difference between them. Self-recognition and tolerance. Self-tolerance is the immune system's ability to difference between its own cells and foreign substances that are non-self. major complex 1 and 2 MHS 1 and MH2 play a critical role in the process. MH2 is found in antigen presenting cells, APC, antigen presenting cells, APC, including macrophages, dendritic cells, and B cells. MG1 is present on the surface of the all nucleate cells and act as self-identification markers to prevent the immune system from attacking. Hypersensitivity is a condition. Hypersensitivity is a condition in which a person's immune system reacts abnormally to an antigen that has previously encountered. Type 1 IgA, type 2 IgG, and IgM. Type 3 immune complex can lead to reaction causing tissue damage, leading to condition including lupus and rheumatoid arthritis. Type 4 T cells transplant reaction during the process of transplanting organs. The recipient's immune system may detect it as being foreign. There are three clinical stages of rejection: hyperactive rejection, active rejection, and chronic rejection. May happen over many years. Autoimmune diseases. A healthy immune system protect the body against illness and disease, but in the case of autoimmune disease, they wrongly attack health cells, damaging physiological function, which in some cases can be fatal. Lupus is a condition in which antibodies are produced by an individual immune system to attack the body tissues. The body issues. Acquire immunity. Acquired immunity is built over a lifetime and can be broken down into active and passive subgroups. Active immunity develops following direct contact with infection against or antigen. The body immune system generates an adaptive immunological response by producing memory B cells which remember the pathogen and upon re-exposure can rapidly create an immune response. Vaccination and immunological memory. A vaccine contains skillet of weakened form of virus, DNA, and RNA, which is injected into the bloodstream for protection against various pathogen strains with antigen variation. Other vaccine may contain multiple different antigens. Herd immunity is defined as protection from infections and to prevent preventable disease as a result of individuals living with a community where a large number of the population are vaccine or have natural immunity against the disease. Vaccination protect individuals from serious disease. There are a number benefits of vaccination. Vaccination program improve the quality of life for millions of people, protecting them from viral disease that remain prevalent, including measles, mumps, and hepatitis B. Vaccination have helped many countries control bacterial infection like tetanus, diphtheria, and whooping cough. Thank you very much for your attention.